All right, we're about ready to wrap this up. We're going to do these two problems. All right, so you can see in a heartbeat. Now this gets us through Monday, so that's not bad. So I got it out on Thursday. I mean, I apologize. I had to watch this on a weekend. God, shoot me now. But hey, anyway, that's kind of screwed us up. I'm going to be out of pocket all day tomorrow after our class. I got to babysit a sick grandbaby. It's going to be great, you know, mainly because grandma's going to be there too. That always helps. All right, so here we go. Now, in a heart rate so this is a pulses delivered to a heart 81 times per minute. So what is the time? Well, how many times between pulses? What's the time between pulses? Well, if we got 81 times per minute, 81 pulses per minute, then that would be 1 times 1 minute over 60 seconds. Boom, boom. So we get 81 over 60 is equal to the pulses, now the pulses per second. And so the time between pulses is 1.35 seconds. That's not too, all right? Not too bad. Now, this thing is discharging. Now the equation for charging in RC circuit, charging is Q is equal to Q naught times 1 minus e to the minus t over RC. Okay. But this is discharging. And it's already lost 63.2%. So discharging looks like this. Is Q is equal to Q naught, because it was already fully charged, times, you get rid of the 1 minus, times e to the minus t over RC. Okay, so what's left? 100 minus, so I've got, it's already lost 100% minus 63.2, which I'm tired, so 100 minus 63.2, 36.8%. So it's lost 36.8%. Okay? So you might be going, well, I don't know what Q naught was. Sure you do. Sure you do. Because we know this. This is that Q is equal to, now is 0.368 of Q naught. So when I put that in there, I get 0.368 of Q naught is equal to Q naught times e to the minus t over RC. And I've been given R. There's R. I need to find out what C is. How the heck do I tease that out of there? But look at this. This is pretty cool, because that at least cancels. So I've got 0.368 is equal to e to the minus t, which I know is 1.35, divided by RC. Okay. Well, let's flip. Remember, this is the same thing. This is equal to 1 over e to the positive t over RC. So let's multiply. Let's flip both of them. Okay, so I'm going to get e to the t over RC. So I'm multiplying both sides by this is equal to 1 over 0.368. So e to the t over RC is equal to, what's 1 divided by 0.368? 2.717. And let's go ahead and put in the 3.9 now. All right, now, you remember how to get rid of this? Let's take the natural log of it, because remember, e to the x, the natural log of e to the x is equal to x. Remember that little rule? So if I take the natural log of both sides, so if I take the natural log of e to the t over RC is equal to the natural log of 2.71739. So I'm not putting any numbers in here. Okay, so this becomes, let's just carry this on down here because I'll have plenty of room to solve this over here. So we've got T over RC is equal to the natural log of 2.71739. All right, so I know what T is. I got to solve for C. So I'm going to get T over R times the natural log of 2.71739 is equal to C. There it is, 1.35. Yeah, this is going to be a dinky number. The capacitance isn't very big. So the rest is just dibbling and scribbling. Well, okay, some of you don't think I know how to do this. I know how to do this. What was R? 1.8 times 10 to the 6th? Okay, so I'm going to take 1.35 divided by double parentheses because I got to put in a 1.8 second e to the negative 6 to the positive 6. Close that parentheses times the natural log of 2.71739. Double. I think I got to do one more. And that should equal C. Whoop, I'm going to go to, I put in one too many parentheses, I think. There it is, 7.5 times 10 to the negative 7 farads. That makes sense to me. Cool beans. All right, now the last problem of the day is this one. What are we going to do? The circuit in the drawing, remember the time, what is the time constant? The time constant tau is equal to R times C in these things. Tau is the time constant. So this is, so compared to this problem up here, so compared to this guy, this ain't nothing. Okay? That ain't nothing. Okay? So, or 0.75, 10 to the negative 6 farads. Okay, so that's the time. So I just had to find the total resistance there. They're in parallel. You can do that, right? You just take the parallel resistance here. They're in parallel. So you just add those up too. Don't forget the little kilo here and the little kilo there and the micro there. All right? And then you got it. Where R is equal to 1 over 4 kilo ohms plus 1 over 2 kilo ohms. Now remember, you don't have to put in to the minus 1. And in capacitance in parallels, this is equal to 3 microfarads plus 6 microfarads. And then the time constant is equal to RP CP. Here's the cake. Cool beans. That's it.